Hello everyone. In this video, we'll understand about how do we do crashing of a project network so that we can reach or we can find the optimal project, crashed project duration, how we can find out. So this following is an example. Consider the data of a project as shown in the table below. Here we have A to G, some activities, and their immediate predecessors are given. Normal time in days is given, normal cost is given, crash time is given in days, crash cost is also given in rupees. And further, the information says that if the indirect cost per day is rupees 100, find the optimal crashed project completion time. So that is what we need to do. Now, for the solution, what we will do first is we will first create one column additional where we will calculate slope cost. We will calculate. So here, additional column I am creating slope cost in rupees. How do we calculate the slope cost? It is a crash cost minus normal cost divided by normal time minus crash time, which means in the first one, we have 750 minus 600, which is 150, divided by 6 minus 4, which is 2. So that means 150 divided by 2 will get 75. Next one, 450 minus 400, which is 50. The whole thing divided by 50 divided by 5 minus 4, which is 1. So 50 divided by 1 is 50 only. Next one, 1650 minus 1200, which we get 450. 450 divided by 6 minus 3, we get 3. So 450 divided by 3, we get 150. Next, 1360 minus 1000, which is 360. 360 divided by 7 minus 4. 7 minus 4 is 3. So 360 divided by 3, we get 120. So 120 is our slope cost for that. Next, 550 minus 500, which is 50, and then 10 minus 8, which is 2. So 50 divided by 2, we get 25. Next one, 910 minus 800, which is 110. 110 by 5 minus 4, which is 1. So 110 by 1 is 110. Then the next one, 1660 minus 1500, we get 160. 160 divided by 4 minus 3, which is 1. So 160 by 1 is 160 only. So we calculated the slope cost for all the activities, right? Now, the first step for any project network related problem is to create the network. So here we may notice activity A do not have any preceding activity. So we will start with drawing a node. Then from there, we will draw this activity is our activity A. And we will write down the normal duration, which is 6 days. So A, 6, I will put. Then activity B can start after completion of activity A. Activity C can start after completion of activity A. D also can start after completion of activity A. So from this end node, I will put this as node 1, node 2. From node 2, I will start 3 activities like this. 1, this another one, rather extend this, another. So one we will call it as B, this will call it as C, this we will call it as D. Okay, now B has a normal duration of 5 days, C has a normal duration of 6 days, D has a normal duration of 7 days. So let me put a node here. Right. So we will give some numbering to this. 3, I'll call this as 4, this as 5. Okay. Now, activity E can start after completion of activity D. Before I draw this E, I will see whether E is getting merged with anything. Yes, it is getting merged with C. So which means When I draw this E, I will ensure that it will merge with what do you call C also, like this. Means from this, when I draw E from D, I will see that sorry, here it should be not D, it is B. Yeah, sorry. So if I want to start E, E can start after completion of B. B is getting completed at node 3. From there, I need to start E. And before I draw E, I am checking for E whether it is getting merged with anything. It is getting merged with C. So I will draw E like this. This is our activity E, and E is going to take a normal duration of 10 days. Right. Let me redraw this. Yeah. Then activity F can start on completion of activity C and E. Then I will check whether F is getting merged with anything. F itself is not occurring in any of the immediate predecessor, which means that F will go to the last node. Like this. I'll call this as activity F, having a normal duration of 5 days. Then activity G can start on completion of activity D. And I'm checking whether G is getting merged with anything. G is not occurring in any of the immediate predecessor. So I will go to the end node to complete that G. So from here, I will call this as activity G. G is going to take 4 days, normal time. So this we will call it as node 6. Now the network is ready. We need to find out, the next step is to find out the, what do you call, critical path. For that, we will start with our forward pass and backward pass. For that, we will create a home-like structure like this. For every node, we will, so let us draw that home-like structure in each of the node. So first we will do forward pass calculation. So to start with node 1, it is 0. Then you come to node 2, you check how many arrows are coming to node 2, only one arrow which is coming from node 1. So you add the 0 and the 6, you get 6 here. Then you go to node 3, you check how many arrows are coming to node 3, only one arrow is coming to node 3, which is coming from node 2. So at node 2, you have the time as 6 and 6, and then you add the duration of B, activity B. So 6 plus 5, you get 11. You fill up 11 here. Then you go to node 4. At node 4, you check how many arrows are coming to node 4. Only one arrow is coming from node 2. So 6 plus this 7 you add, and then you write 13 here. Then you come to node 5. At node 5, you check how many arrows are coming. There are 2 arrows coming. One is coming from node 2, one is coming from node 3. If I calculate it from node 2, it is 6 plus 6, 12. If I calculate it from node 3, it is 11 plus 10, you get 21. You need to choose the maximum when you do a forward pass calculation. So you consider here 21. At node 6, last one, you check how many arrows are coming. There are 2 arrows coming. One is from node 4, one is from node 5. If you calculate it from node 4, it is 13 plus 4, 17. If you calculate it from node 5, it is 21 plus 5, 26. You choose the maximum, which is 26. This is forward pass calculation. Now you have to do backward pass. Start from the last node, go to the first node in sequence. So at node 6, you start with the 26 only, whatever you wrote in the rectangle. You wrote the same thing in the triangle, 26. Then you come back. The previous node is node 5. At node 5, you check how many back arrows are there. Only one back arrow, which is from node 6. So you consider the number which is written in the triangle, which is 26. 26 minus 5, you subtract the duration, you get 21, so you write 21 here. Then at node 4, you check how many back arrows are there, only one, which is from node 6. So 26 minus 4, you write to 22 here. At node 3, you check how many back arrows, only one back arrow, which is from node 5. So 21 minus 10, you write 11 over there. At node 2, you check how many back arrows. You have actually got 3 back arrows. One is from 3, one is from 5, one is from 4. If it is from 3, it is 11 minus 5, 6. If it is from 5, it is 21 minus 6, which is 15. If it is from 4, it is 22 minus 7, it is 15. You need to choose the least when you come backward. So 11 minus 5 is the least, so you write 6 here. When you come to node 1, you check how many back arrows. It is only 1, which is from 2. So 6 minus 6, you write 0 here. Now the critical path is wherever the common numbers are occurring, 0, 0, 6, 6, 11, 11, 21, 21, 26, 26. That means the critical path is this 1 to 2, and then 2 to 3, and then 3 to 5, and then 5 to 6. So I can write here, critical path is 1 to 2, then 2 to 3, then 3 to 5, and then 5 to 6. In terms of the activities, critical path is 1 to 2 is nothing but A, 2 to 3 is nothing but B, 3 to 5 is nothing but E, and 5 to 6 is nothing but F. So that is our critical path. So the total duration of the project is 26 days. So we can say the total duration, or I can say the normal duration. The normal duration to complete the project is 26 days. Now let us calculate the cost. First we will calculate direct cost. Direct cost is nothing but total normal cost. Total normal cost. So which is given already in the question. We need to add and see how much it is. Let me just introduce one row here. So here I will write total. So here we are going to calculate the normal cost total. So 600 plus 400, it is 1000. 1000 plus 1000, 2000. 2000 plus 1200, it is 3200. 3200 plus 500, it is 3700. 3700 plus 800 is 4500. 4500 plus 1500, we get 6000. So the normal total normal cost is 6000. So here I will write rupees 6000. And the indirect cost, day-wise, it is given in the question as per day it is going to, we are going to incur 100 rupees. So 26 days is the total normal duration. Into rupees 100, we get rupees 2600. That means the total cost is equal to rupees 8600. So till this, we call it as iteration 1. We'll say this as iteration 1. Now we will have to start our crashing activity. We'll call that as iteration 2. Now we will create a table wherein we will consider the critical activities. There are 4 critical activities. So we'll create a table like this. Sorry. I'll insert a table having, let us say, 3 columns. And there are 4 critical activities. So I will keep one for title. So we get like this. So here I will write critical activity. And here slope cost, which is in rupees. And then we will calculate crash limit for that activity. Means how many days we can able to do crashing. That is in terms of days. Okay. So now critical activities we already identified, and those are your A, B, E, and F. So here it is A, B, E, and F. Now, slope cost we already calculated. For A, it is 75 rupees. For B, it is 50 rupees. For E, it is 25 rupees. And for F, it is 110 rupees. So we will write those 75 and 50, 25, 110. Crash limit, how it is calculated? We may notice for A, it is 6 minus 4. Normal time minus crash time will give you the crash limit. 6 minus 4, we get 2. And for B, it is 5 minus 4, 1 day. It means maximum you can crash only to that extent. That is what is crash limit. And for E, it is 10 minus 8, 2 days. So 10 minus 8, 2 days. And then for F, it is 5 minus 1, sorry, 5 minus 4, 1 day. So that is what is the crash limit available. Now, the least slope cost we choose because we want to spend less. So what we will do, we will choose activity E, which can be crashed to the extent of 2 days. That means we can think about reducing this activity E by 2 days, whether that will be possible or not, if we can reduce it by 2 days. So again, we have to draw the same network diagram. One, two, three, 4, 5, and 6. This is activity A. There is no change in the duration of activity A, and it was 6. So I will write 6 only. Activity B, it is 5 days. Activity C, it is 6 days. Activity D, it is 7 days. Activity G, it is 4 days. Only we are planning to do reduction in, sorry, activity F also will be the same. That is 5 days. We are planning to reduce activity E by 2 days. So let me reduce that. Earlier it was 10 days. Now let me make it 8 days. Now we need to see whether there is any change in the critical path. Change in the critical path is not allowed, but you can have new critical path, additional critical path without affecting the existing critical path. The existing critical path should not go. It should be remaining there. If that is so, then you can proceed with that particular crashing. So here we are going to check now, will there be any change or not? 0 plus 6, it is 6. And 2 plus 6, 6 plus 5, it is 11. Here it is 6 plus 7, it is 13. Here it is 11 plus 8, 19. And here also we need to, sorry, 6 plus 6, it is 12. So I should consider 19 here. Here it is 19 plus 5, 24. So backward pass, 24 minus 4, it becomes 20. Here it is 24 minus 5, 19. And for 3, it is 19 minus 8, 11. And for 2, it is, no 2, it is 20 minus 7, 13. Here it is 19 minus 6, 13, 11 minus 5, 6. Finally, this is 0 only. Now there is no change in the critical path. It is still, I will write, no change in the critical path. And it is remaining as A, B, E, and F only. A, B, E, and F only. No change in that. Now, let us calculate the cost now after this crashing happened and see whether the cost is going down or not. If it goes down, you can continue with crashing. If it goes up, then it is not worth it. The previous cost is the optimal cost. That is what we will try to conclude. So first, let us do direct cost. Sorry, I can do this in a different way. Total cost now is equal to previous total cost plus crashing cost, because you are spending money for doing the crashing, minus savings. So now previous total cost we already calculated as 8,600 rupees, 8,600 plus you crashed 2 days, and each crashing, how much you are spending for E, that is your slope cost, 25 rupees you spent. So 2 into 25. How much saving you did? You saved 2 days, because 26 days gone down to 24 days. And each day saving, you are going to gain 100 rupees. That 100 rupees indirect cost will be saved. So you landed up with, this is also, everything is in rupees. So you landed up with rupees 8,600 plus 50 minus 150, which will give you rupees 50 minus, sorry, this is 200, sorry. Means 150 is getting minused, so you get 8,450. So we can say now, since, let us call this as TCN, total cost now. This is previous total cost. This is crashing cost. This is savings. We are just using some abbreviations to that. Since total cost now is lesser than previous total cost, we continue with crashing. Crashing further. So we will proceed to the next iteration, that is iteration 3. So in iteration 3, again, you will be drawing the same table. Let me copy this table. This is actually F. Now, activity E is fully crashed. 2 days are gone. So I will have to put here dash. Since there is no available limit available, there is no point in having a cost there. I will put dash over there. So now among these remaining slope cost, that is 75, 50, 110, the least is 50. So I'll put a star over there now. And you have a crashing limit of only 1 day. Means you can reduce this activity B instead of 5 to 4 days and see what happens to the, what happens to the cost. Means what happens overall. That is what you try to do. Let me copy this. Then I will modify. Okay, we decided that we will crash this activity B by 4 days. So let this all will change now. Let me change it. Let me try that. So this B, earlier it was 5 days. Now you are trying to crash it to 1 day. That means it will become 4 days. Now 6 plus 4, it becomes 10 here. And I will have to rub this also. Yeah. Okay, 10 days. And then for this 6 plus 7, it becomes 13 days. And here it is 10 plus 8, 18. 6 plus 6, 12. You need to consider the maximum, which is 18. 18 plus 5, 23. Here it is 13 plus 4, 17. So you have to consider 23. Now backward pass, you start with 23. So you go back, 23 minus 5, it is 18. Should remove this. We need to check whether the critical path is remaining the same or not. Yeah, I'm sorry. Then 23 minus 5, 18 we did. And then at 4, it is 23 minus 4, it becomes 19. At 3, one back arrow, 18 minus 8, it is 10. And at 2, 10 minus 4, 6. And then here it is 18 minus 6, 12. 19 minus 7, it is 12. So the least we have to consider, which is 6 only. So this becomes 0 only. So that there is no change in the critical path again. It is A, 1 to 2, that is A, B, and then E, and then F. So I will say no change in critical path. So we can again calculate the cost. Total cost now is equal to previous total cost minus crashing, plus crashing cost minus savings. Previous total cost is how much? It is 8450 plus crashing cost. We crashed now activity B. B's cost is 50 by 1 day. Overall, it is reduced by 1 day. Earlier, it was 24 days. Now it has gone down to 23 days. That means 1 day, B, you spent money, 50 rupees, 1 into 50. And there is a savings of 1 day, 100 rupees, which means overall there is a saving of 50 rupees. So you can say rupees 8,400. Since the cost is reducing, since total cost now is lesser than the previous total cost, we continue with crashing. So again, we have to move on. Till now, we did 3 iterations. Now, 4th iteration. We need to again draw the table, this table. Let me copy that table. So in that, we already crashed activity B. I need to remove this. That 1 day got exhausted and put a dash over there. Now we may notice the least cost is for activity A. So put a star there. Activity A, you can reduce it by 2 days. Maximum you can reduce it by 2 days. So first let me copy this diagram. Then we can modify. The numbers. We are planning to crash now activity A. So I will remove that number. Okay, now let me draw this, whatever is missed now. Yeah. So activity A, we decided to crash it by 2 days, right? So we can think about activity A earlier, how many days it was? It was having 6 days. We are planning to reduce it by 2 days. That means I will make it 4. Now, if we calculate 0 plus 4, it becomes 4 here. And then 2 to 3, only one arrow, which is from 4. So which is from 2. So 4 plus 4, it becomes 8. And at 4, it is 4 plus 7, 11. At 5, 8 plus 8, 16. 4 plus 6, 10. So I need to consider the largest, which is 16. And here 16 plus 5, 21. 11 plus 4, 15. I need to consider the largest, which is 21. Start backward. I will start with the 21. Now 21 minus 5, it is 16 only. Here only one back arrow. 21 minus 4, it is 17. Then at 3, only one back arrow. 16 minus 8, it is 8. Then at 2, there are 3 back arrows. 8 minus 4, which is 4. 16 minus 6, it is 10. 17 minus 7, it is 10. So I need to choose the least, which is 4. So here it is 0. Now again, there is no change in the critical path. 0, 0, 4, 4, 8, 8, 16, 16, 20, 21. No change in the critical path. So now, since there is no change in the critical path, let us calculate the cost. Total cost now is equal to previous total cost plus crashing cost minus savings. Previous total cost is how much? 8,400 plus crashing cost. We actually crashed 2 days for activity A. Activity A, the cost is 75 rupees per day. Minus, you saved 2 days. Reason is, earlier it was 23 days. Now it has gone down to 21 days. You saved 2 days. So 2 multiplied by 100, which means this is 150, this is 200. Ultimately, we saved around 50 rupees. So this becomes now rupees 8350. Now again, we'll say, since total cost now is lesser than previous total cost, we continue with the crashing. So we proceed to the next iteration, which is iteration number 5. Now I will copy this table. We already crashed activity A fully 2 days. So I will rub this, put a dash instead. Is this actually something wrong? 5 minus 4. Here also 5 minus 4. Here also 5 minus 4. Now, there is only one activity for crashing, that is activity F, which is going to cost you 110 rupees, and you have only 1 day to crash. But is it worth to crash that? It is not worth. Reason is, saving per day is 100 rupees, whereas the crashing cost will be 110 rupees. So I can say, we will not crash activity F since the cost of crashing per day, which is rupees 110, is more than the savings, which is rupees 100 only. It is given in the question, right? Hence, the optimal cost we could get is rupees, whatever was the previous, what was that? 8350 only. 8350. And the optimal duration is, what was the previous duration? 21 days. 21 days. So 8350 is the best cost or optimal cost, and the optimal duration is also 21 days only. So that completes this particular problem. Thank you all for watching.